Alright, a little about this setup. I have mounted the whole thing on my engine crane, which is chocked and blocked so it can't move. Very stable at the moment. Here I have a board which you see down the bottom. We have a right hand bend. That is going to be where our nozzle comes out, and the water of course. At the moment it is plugged, and there's a reason for this. 1 inch tube goes up, goes to this garden hose here, which is in a loop, and that continues on down the frame of the engine crane and down the side of it there, round in a bit of a coil and back to the two-way splitter on the tap. Now this is good in that by opening this side, it has nothing connected to it at the moment, but later on the pressure cleaner will be connected to it. But by opening this tap I can relieve the pressure within this system here once this tube is full of water. So once the tube is full of water and the pressure is released, we'll zero out our scales, which has this very fine stainless steel wire that goes all the way over here and is mounted to the close line, which is mounted to the wall. So that end and that end cannot move. On top of the board we have a hinge, and this is to allow the board to move backwards and forwards, which will show us our thrust. Now the scales are set at a 3:1 ratio to the bottom of the board, or the outlet nozzle. That means what we will see on the scales is 3 times the amount of actual force we have coming out of the nozzle. Here I have a spring which is tied back to the engine crane, and that allows me to get some tension on our scale and the wire that's holding it up. So having tension on it's alright. Once we're set we just zero it out and we'll be measuring any force after that tension. Okay, so our first test is going to be to put pressure in the system and make sure this hose here is not going to be providing any sort of force pushing back or forwards on this swinging beam here. I have my high pressure cleaner mounted to a heavy battery by hose clamps, and the trigger is wired off. So that's going to be the last part of our test. Now you'll see a white line going there. That is the 45-degree angle to the outlet nozzle, and of course 90 degrees straight across. So what we're trying to do is keep all our water coming from the nozzle inside that 45 degrees for the first test. So first we're going to switch on the tap, fill the tube up with water. I've left it a little loose up the top here to allow any air to come out, but you can hear the tube filling up. Once it's full we'll turn the scales on so they are zeroed out, and we'll release the pressure before we turn the scales on. Make sure they're zeroed out, and we'll apply the pressure again to make sure this hose is not applying any force to the beam. So we shall turn our tap on, like so. You can see it running out the bottom, out the top. Now the tube is already full because I've been messing around with this quite a lot since the beginning of the day. So I'm going to turn the tap off, and I'm going to release the pressure inside the system like yay. And now we're going to turn our scales on and let it steady, and there we have our zero. And the wind is blowing a bit, as you can see. Of course it would start now, but there we go. So we'll turn our tap back on. So the pressure is up, leaking at the bottom. As you can see, other than the wind blowing it backwards and forwards, we have a steady zero reading. So we know the pressure in the pipe is not causing any force back on the device in that test. Okay, so I'll go ahead and set up the next test. What we're going to do is put this here nozzle in there where the plug is, zero the meter out once again, and turn on the system and see what kind of a reading we get on our scales. Back shortly. Okay, we're set up for our second test, and what we're going to do, I wish this wind would get lost. Of course it only started once I started doing this test, but as you can see the wind's blowing a little bit. That just tells you how accurate these readings are going to be. So we can minus up to 20 grams off of these tests if you like, if you wish to think that the wind has anything to do with what's going on. So our nozzle is in, our scales are zeroed. Now what we're going to do, I have the pressure cleaner also hooked up and turned on, and water will start coming out of there once I turn the tap on, because I have the triggered wide open. So we will get a little stream of water coming out of there under our mains pressure. We're going to turn on our pressure cleaner here, because once we do that and it starts moving a lot of water, we're going to see a pressure drop here. So we're going to have the pressure cleaner running, and then we're going to see what our scales tell us, and that is the reading we'll be using for the rest of the testing to compensate for the loss in mains pressure due to the high pressure cleaner. So I'm going to switch on the tap now. And this is where we start getting wet. Okay, you can see we have a little bit coming out of the pressure cleaner. And by the way, the pipe was already full, believe it or not. The nozzle on the bottom will not let the water out because it is too small. The water wants to come out but the air wants to go back in, so the water remains in. So now we're going to turn our pressure cleaner on. This is where it gets noisy, so we're going to turn it on and get our scales reading. So there we have 435. And as you can see, the pressure's dropped quite a lot. Hardly any there at the moment, because this is using a lot of it. Okay. So without the pressure cleaner running, just that little tiny bit of water coming out from the mains pressure, you can see we have a better flow there now, and we also have a better reading on the scale, more pull force on the scale. So I'll just show you. I'll turn the tap off, and also this one for the pressure cleaner so it can't suck air back that way. And I just ran into this wire that I can hardly see. But you'll see the water's not coming out of the pipe. So the pipe is still full, and our scales are once again back at zero. So that can discount the pipe filling with water, and it's only on the other side of the board, 19mm pine to the hinge, so it wouldn't be doing that much anyway from empty to full. But just to show you, I'll take the bung out, or the nozzle out, and you will see that the pipe is, and was at the start of the test, still full of water. So now you can see the water drains out of the pipe. By doing this, we can also have a look at the scales now, which should give us a small negative reading, which it does, about, well, between nothing and 20. Now that the wind has died down, it's still showing 0. So that's telling us that that tube, even if it was filling up with water, after we started the test is not doing anything on the scales. Our next test, of course, is I'm going to put the nozzle back in. I'm going to make up a bracket that's evenly weighted on both sides, that's going to sit in front of the water coming out of the system, and we're going to see our equal and opposite reaction, whereas our scales should once again read close to 0, if not 0. So I actually have to fabricate this bit now, so I'll go and do that and then I'll be back. So what I've done here is I've just bent up a bit of clear acrylic, and we have that of course in front of the nozzle and screwed to the board. Now I was going to balance it, but it doesn't have to be balanced because we're going to zero the scales out before we start the test. In theory we should get a 0 reading, our equal and opposite forces acting upon each other, thus giving us a net result of 0. So what I'm going to do is prime the pipe up first, just to make sure it's full, which it is. A little bit of air in there. Okay, we turn it off softly so the water doesn't bleed out. That pipe is now full. We turn our scales on. Now reading 0, and we should get a net result of 0 once we turn our water back on. That's full mains pressure now. We're not running the pressure cleaner, we don't have to for this test. So at the moment you can see, other than the wind blowing it around a little bit, once it stabilises we do indeed have 0. So that's what we expected, and that's just another confirmation of the test that nothing else is going on. The pipe's not filling up with water and adding to the pull force on the scales. Alright, so the next test we're going to remove our deflector plate, or our backstop, whatever you want to call it, and we're going to place the high pressure nozzle so it's at right angles to the jet coming out, and we're going to see if we can keep the bulk of the water within that 45-degree line there, which is almost washed off. I will remark again for the next test, and that will be the end of this series of tests. Of course our next test we will be bolting this high pressure cleaner to the pendulum itself, so as it pushes the water downwards, and see if we still maintain a thrust. Now the only problem with that is it's going to be mounted offset to the hinge up the top, so it's actually going to want to push the board at the bottom. The board will want to travel this way, which is going to be against us, so we're going to see a smaller reading on the scales, if any at all, than what there actually is. So I'm going to, if that comes up to be the case, I'm going to have to try and rig it so that the high pressure cleaner part is almost directly underneath the hinge and pushing straight up against the hinge. So my expectations are that once I bolt this onto our pendulum, it will indeed want to make the bottom of the pendulum go that way. So we'll see how we go then when we get there, and modify it as necessary. So I'll go ahead, set the next test up to see if we can get most of the water inside that 45-degree line, and coming from that jet, and maintain our thrust force on the or the pull force on the scales, which indicates our thrust at the bottom. Back shortly. Alright, so we're all set up ready to go for our last test for the day. Like I said, the next step will be bolting the pressure cleaner nozzle to our pendulum as well. The tube is full of water. We are set at 0 degree, or zero. The scales are zeroed out, should I say. So the idea here is to get the bulk of the water inside this side of the board, which is our 45 degree mark to the nozzle here. So we want most of the water coming out of the nozzle to be deflected as far around to 180 degrees from our high pressure cleaner nozzle, or 90 degrees from our outlet, as much as possible. So like you've seen in the second part of this video, once we turn the pressure cleaner on, the flow rate from our ejector nozzle drops down. The pressure cleaner uses 5 litres a minute, and with that running I've measured the output on our ejector nozzle at about 50 to 55 litres per minute. So we have a whole lot more water coming out of our ejector nozzle than we do the high pressure cleaner nozzle. However, like you've seen, once we start up the high pressure cleaner, it does indeed rob some pressure out of our ejector nozzle, and thus the scales will drop down. So a little bit of wind movement there, not much. So we're going to start her up. I'll switch the tap on first. Oh, wrong way. Okay, and you can see we have a little bit of water coming out of our high pressure cleaner, but that's just mains pressure. The bulk of it, and my scales have just turned off. Oh, what a pain. Well, it means we have to start that again, but at least we'll know the pipe is choco full of water. Alright, so I'll turn that on. 0 degree, oh, 0. Right, we're zeroed out. I'll turn the tap back on. Like yay. We have 575, about 570 to 580 grams full force there. But as we can see, the bulk of the water is going straight out, and in the last test you would see that means that you give us a net force of 0 from our pendulum setup. So we're going to switch on the high pressure cleaner. We want the bulk, like I said, of the water to be on that side. So let's start the high pressure cleaner up, and not forgetting the drop we're going to see in pressure. Now I don't know how clear you can see that, but we've got nearly all of the water inside that 45 degree mark. The bulk of it is now 90 degrees to the ejector nozzle. The interesting thing is we have a lot more going backwards, which would more than compensate for that little bit we got on this side of the 45 degree line. And we are still maintaining 450 to 470, around between 460 and 480 grams of full force on the scales. And of course now it'll go back up as it did before. So let's turn that off. And there you go. So we managed to get nearly all of the water inside the 45 degree line, and what was outside was a whole lot less than what was actually going backwards to the water flow coming out of the nozzle. Now the stuff that's going backwards will assist in the overall thrust of a reactionless drive system. So far looking good. If we can achieve the same with the high pressure cleaner nozzle bolted to our pendulum, then we're well on our way to something quite exciting. Thanks for watching, guys.